Here we have honest free characters column on the board. Okay, let's go with the question. If log k to the base 2 equals to 1 half and cosecant theta equals to k, where 90 degree less than or equal to theta less than or equal to 270 degree, then the value of theta to the nearest degree is. Okay, first let me take the given equation, that is log k to the base 2 equals to 1 half. Okay, so the first thing what I'm going to do is I'm going to convert this equation to exponential form. It's already in logarithmic form. Okay, to convert this equation to exponential form, what I need to do is I have to move this log along with its base 2 to the other side of the equation. When I move this log with its base 2 to the other side of the equation, I have to ignore this logarithm. I have to consider only the base 2 on the other side. So the value which already exists on the other side will become the exponent. And k equals to, so whenever the exponent is 1 half, so it can be written as square root. So then 2 to the power 1 half can be written as square root of 2. Okay, now so we can plug in cosecant theta for k, because there is an information cosecant theta equals to k. So we can plug in cosecant theta for k, then we get cosecant theta is equal to square root of 2. Okay, so we can convert this cosecant theta to sine, because cosecant is the reciprocal trigonometric ratio of sine. So it can be written as 1 over sine theta. Because if I convert this one to sine, I can get the, I'll be able to find the angle measure theta from the trigonometric ratio table easily. Because we can use trigonometric ratios ratio table for sine, cosine, or even unit circle. So that's why I'm converting this cosecant theta to sine theta. So since cosecant is a reciprocal ratio of sine, so for cosecant we can write 1 over sine, we have square root of 2. Okay, now so I have to solve for sine theta in this one. So for that I have to take reciprocal on both sides. The reciprocal of 1 over sine theta is just sine theta, and the reciprocal of square root of 2 is just 1 over square root of 2. Okay, to rationalize the denominator, I multiply both numerator and denominator by square root of 2. So sine theta equals to 1 times square root of 2 is square root of 2, and square root of 2 times square root of 2 will be just 2. Okay, now I got the value of sine theta. Okay, so from the trigonometric ratio table or unit circle, so for what angle measure of theta from 0 to 90 degree? So 0 to 90 degree. So here I have a question. So the question says 90 to 70. That we can do it later. So initially we have to find the angle measure, the first quadrant, that is from 0 to 90 degree. So from 0 to 90 degree, for what angle measure of theta, the value of sine is square root of 2 over 2. So from trigonometric ratio table or unit circle, we get theta is equal to pi over 4, or I mean 45 degree. Okay, now I got an angle measure in the first quadrant, 45 degree. Okay, let me complete the quadrants here, 0, 90, and here we have 180, and here we have 270. Okay, now I got the angle measure of the first quadrant from 0 to 90, but according to the question we have to find the value of theta from 90 to 270. Okay, then what we need to do is we have to consider this 45 degree angle measure in the second quadrant as a reference angle. So here you may have a question, why don't we consider this 45 degree in the third quadrant? Because from 90 to 270, the two quadrants are covered, second quadrant and third quadrant as well. So here the value of sine theta is a square root of 2 over 2. It's a positive value. So the sine theta is getting a positive value in the first quadrant and the second quadrant. Only in these two quadrants sine theta is positive. In third quadrant, the sine theta is negative. So we cannot consider, even though the given domain covers the third quadrant, we cannot consider third quadrant over here, because in third quadrant sine theta becomes negative, but here we got a positive value for sine theta. So that's why I'm saying that I have to consider only the second quadrant over here. So in the second quadrant, I have to take this 45 degree as a reference angle. Okay, now let me take this 45 degree as a reference angle. If I take 45 degree as a reference angle, what angle measure should I have over here? So for that, I have to subtract this 45 degree from this 180. When I subtract 45 from 180, I'll be getting 135 degree. So the sine theta is equal to square root of 2 over 2. We'll be getting this value for sine theta when theta is equal to 45 degree in the first quadrant, or theta is equal to 135 degree in the second quadrant. When theta is equal to 45 degree in the first quadrant and theta is equal to 135 degree in the second quadrant, so we'll be getting this positive value square root of 2 over 2 for sine. But according to the domain, so we have to accept the second value, because 45 degree does not come in this interval between 90 and 270, but 135 degree comes between 90 and 270. So the theta equals to 135 degree.